right. Welcome, everybody. Here we go. Looks like we're good to get started. I love it. People are already putting their names in the chat. That's great. So I'll wait a few more minutes to take roll just so some more people can come in. That's great. So remember, a couple things I need by tomorrow. And there's not much you can do about one of them now. Is your attendance needs to be good. So good attendance. And then if you're you need to do some homework. Whoops, I'm on the wrong class here. I was looking at this before. That's the wrong one. I was looking at this before during office hours, but I am on the wrong class. So let's see. Let me get to the right one. Here we go. Statistics, right? I was almost getting ready to teach my calculus class this morning, but that's the wrong class. We're statistics. So, okay, so I'll give people a few more minutes, and then we'll get started here with the roll. Starting, I don't know if I'll do it tomorrow, but I might do it tomorrow. So you kind of have to be ready tomorrow. Remember, I have to start dropping people in the class who aren't participating. And don't panic. I know sometimes students get really nervous and they're like, I've missed one class and I didn't do one assignment. And then you don't have to worry, right? I understand if people are slightly behind or haven't completed 100% of the assignments so far, that's okay. But if if you haven't really shown up to class, like if you missed 2 of the 3 meetings, is it 3? Yeah. Oh, wait a minute. I'm looking at the wrong roll sheet. This is, it's this one. So of our class meetings, which there's, let's see, today is what, 5? I think 5 class meetings, and you've missed 3 of them or something, then and you haven't let me know why, then you might be getting cut. If you have done very little homework, you kind of know. Have you done a reasonable amount of homework that I can sit there and tell a dean, well, the person did this much work, so I thought they were participating in the class, then I'm not going to drop you. I'm not looking to drop people from the course, but it's a thing that I have to do. Whoops, let me change this setting here. It's a thing that I have to do, so I have to be able to say that I'm doing my job properly and fulfilling my contract. So use common sense. If you've done little to no homework, you're probably getting dropped. So make sure that by tomorrow, when I would be potentially looking at this stuff, that you have that done and you can justify, hey, I was participating in the class. Okay, then I'm probably not going to drop you, right? Okay, looks like we got enough 4 minutes in. We're probably good. So today's what, Wednesday? So we got what? Okay, and then I will check over here. We got Okay, so people who I have marked as absent are the following. Jose A, Willie D. Pretty sure Willie D is a no-show for the semester. So what was that? Jose A, Willie D, Litzy E. Not seeing Litzy E. Juan G. Looks like we just got Luis L. Okay, you're here. Got you, Luis. Um, and then I'm sorry, Donovan. Can you remind me the what your last name starts with? I've got two similar names on my roll. I want to make sure I'm marking the right person. If you're there. Otherwise, I'm going to end up probably not dropping someone if I get my names mixed up. Okay. Okay. Oh, there we got Litzy. Okay, I gotcha. Okay. Okay, I think we're good with roll. So I'll have to compare this. As far as attendance, people are pretty good here. I'll just have to I have to compare that with the homework, see who's doing homework, who's not, and then I can make decisions there about who's getting dropped and who isn't dropped. Remember, if you have had a number of absences because of illness and you haven't already emailed me, then email me, or I should say message me in Canvas, because if I'm sitting there and it comes up later, sometimes it comes up later when a student left the class, because depending on when you leave a class, there's different consequences. So they say, well, why didn't you drop this person at census? Well, they didn't have very many attendances. Well, I have a message from them saying that they were sick with COVID and that they shouldn't be dropped. That I need something like that. But most people have been pretty good with attendance in this class. Keep that up, right? Just because census passes this weekend, that doesn't mean, okay, now I don't have to come to class. There is a very clear difference if you look at the pass rates of people who come to class versus the pass rates of people who do not. And then, of course, that's especially true here in a couple of weeks when we're actually going to be seeing each other in person, right? Which will be, this is good. This class is a little on the smaller side, which is great. That means we're not going to be packed in there super tight in a room. While COVID is still going down, we can spread out a little bit. I'll open some windows, get some ventilation in there, and go from there. And at that point, attendance will be important. I will still keep attendance, just so we can, make sure we're being responsible about that kind of stuff. So, and then again, make sure you're getting ready to go onto campus and our return, which appears to be in a little over 2 weeks. Looks like we'll be on campus. So, watch the calendar for that. Okay. I graded the project groups. So those of you who went in and introduced yourself and put yourself out there to form a group, I can't really tell if you formed groups or not, but that's kind of on you to have formed the groups. So if you did not form a group, right? I would say for most people, being in a group by yourself is not a great idea. I have seen students do excellent work all by themselves, but that's really for students who have a really strong set of skills. The students who are used to, I'm talking about like students who generally get A's in every class they take. They know how to sit down, read through a textbook. They know how to find the information that they need, and they're motivated to make it happen. They try to go above and beyond in their kind of work, and really I've had a couple of students, like I'm describing, turn in 40-minute videos for the project. Your project doesn't need to be anywhere near 40-minute videos, but the 2 times people turned in 40-minute videos, they were awesome. I mean, they just laid out, they showed me everything that they exhibited, that they learned everything over the course of the semester, which is really what the project's about, right? Again, we're not doing publishable research. It's about showing me what you learned. You say, oh, well, we talked about hypothesis testing. Here's how I applied hypothesis testing to my project, and here's what I did. And then you convince me that you learned that material. So some students are able to work by themselves, but you really, we're talking about highly motivated students with high levels of student skills, study skills, that kind of stuff. If that describes you, then you might be okay working by yourself. If that doesn't describe you, if you kind of think that you're maybe like the middle of students, like you're kind of a typical student, or maybe you're not very confident, you feel like you're maybe below the average student with your study skills and stuff like that, I highly encourage you to get into a group, or you're going to feel lost at parts in this class. You're going to have no one to turn to and work with, and then you might end up failing. So if you did not end up getting in a group, at this point in the discussion, that doesn't mean you can't form a group. You're just going to have to let me know at this point. Say, oh, I'm trying to get in a group, and I can see if I can pair you up with someone, or if we can get another group to absorb you or something like that. Okay. So please don't let that go. For 95% of students, being in a group is going to be a very big step towards passing the course, and being by yourself for most students is a step towards not passing the course. So don't be, I know people have social anxieties, especially over the last few years where many of us have been quite separated. It's just weird to interact with people, and it can feel uncomfortable, but like, you just got to get over it. You want to pass this class. We're all going to have to integrate back into society at some point. This is a chance to kind of get into that and sort of push yourself outside of your comfort zone a little bit, and get yourself in a group. Believe me, it's going to be helpful when you don't understand how to do the project, or you think you do, right? Sometimes I see students that think they get what to do, or they're using it like a checklist, like, well, I mentioned a hypothesis test, and then you get together with your group and you see what the person next to you did, and you're like, oh, that person did like a really good job. That makes what I did look terrible. Okay, I'm gonna learn from them, and then I'm gonna do a better job on my project. That kind of seeing what other people are doing on their project can be really helpful, because I do get students that just turn in a video where they're just reading in a StatCrunch output. Just, this, we'll be looking at StatCrunch today, and they just read, my regression line is this, and my R value is this, and then they move on. That's basically 0 points. You push 2 buttons in StatCrunch. You're not going to get points for that. You have to expand on that, and that's hard. That's confusing. It takes a while to learn how to do that. So when you see that someone else in your group has done that, you go, oh, that's what I should be doing. Okay. And then you can go back and hopefully, if you have a good relationship with the people in your group, they'll even help you. Most people that are good at stuff are pretty willing to explain, because one, people like to help each other out, but also that act of helping someone else out in the class actually helps the person explaining, right? You'd be surprised about that, but I see this in my classroom. People be working in a group, and someone who knows how to do the problem explains it to the other person, and the person who explained it goes, oh, that actually makes more sense to me now too. So sometimes explaining something to someone actually helps you learn it better, right? So it's kind of beneficial for everybody to go through that. So anyways, bottom line, get yourself in groups, and then start working towards these survey questions. That's due February 6th. I can't push that out any further, because we have to have that data collected so that we can move forward with the other parts of the project. Right? And we already kind of start a little bit behind in the semester, because we can't dive into crunching the data until we have the data. So make sure you've got your stuff figured out at this point. Do remember, right? They all start off this way. Each group member must leave a posting in order to get credit. That's absolutely true. No one's posted here yet, which is fine. It's not due for a while. But you don't want to be doing these questions last minute. You're going to end up with bad questions. I would get together soon, form a concept, put a rough draft of some questions together, and then while you're working through these first couple chapters, you go, oh, I just learned something that makes me think one of our questions is not very good. And then you go back and you kind of redo it. You edit, a revision. Go, this is better. If we word it this way, we're going to get better answers. And then you share that with your group, and then people can go, oh, yeah, you're right. Let's ask it that way. And you're going to get much better data to work with. And that's part of statistics. If you can collect good data, it makes things a lot easier. If you collect your data poorly, your data will either be completely unusable, or it will be a big pain to work with, not as reliable, that kind of stuff. So I wouldn't wait to start working on this as we're working through these early chapters, okay? So take take both what you're learning from me in the class meetings as well as what you're learning in the lessons and the assessments. Okay, so question here, do we know when we're coming back? So you should have gotten an email from the school, so check your school email. I think the return date, like don't quote me, double check what I'm saying, but I think the return date is February 14th, which is Monday, and we're a Monday class. So yeah, so I think our first day back on campus is February 14th. Again, double check. The chancellor sent out a message to the entire district. So that's the update. And from what I'm hearing, they actually think that is when we will be going back. When they first extended things for the first 2 weeks of school, they were already telling us probably not going back in 2 weeks. We're probably going to extend it again. But what they're telling us now is that date that you've been emailed by the chancellor, the school fully expects us to be in the classrooms at that time. And data is supporting that. So nationally, we're seeing this Omicron spike. Basically, we're going to keep seeing this at the holidays. Everyone gets together at the holidays and gives each other whatever version of the virus is going around at that time. You can look at the graphs over the last few years, and you sometimes get a spike in the summer, but every single time since COVID came out, Thanksgiving and Christmas, we get this huge bump, which then carries over into January, and then it starts down again. So, people insist on getting together for the holidays, and they spread it to everybody. But we're starting to see nationally those numbers come down, and there was a report that came out that said locally, in Ventura County and parts of Santa Barbara, we are starting to see the numbers come down again, right? Hospitalizations are still high because they follow, the hospitalizations lag a little bit. Takes an extra week or two for the hospitalization numbers to come down, but we're still kind of seeing that, the big bump that we had for everyone getting together in Christmas is kind of starting to come back down again and dying out. So the scientific evidence would also support that probably we will be back in the classrooms on the I think it's the 14th if I remember correctly. But again, double check that email. Okay. All right. With that said, let's get into, if there's no more questions, let's get into some statistics. So let's look at some things. Then I'll show you StatCrunch today. I'll start giving you a little bit of an introduction to StatCrunch. You want to be comfortable with StatCrunch, but being able to use StatCrunch doesn't mean you know statistics. So it's kind of like, StatCrunch is one piece in the puzzle of completing this class, and it's an important piece, right? It's like you put a puzzle together and one piece is missing. You have a problem. You don't really have a full puzzle there. It's the same thing here. StatCrunch is a very important piece of the puzzle, but it is not the whole puzzle. And I think sometimes students, they talk themselves into that when they're like, oh, I'm going to bluff my way through this. I didn't really learn much, but I'm going to bluff my way through this video. You're not going to be able to do that. Just learn the material. It's very clear when you're talking in a video if you know what you're talking about versus if you don't. And I'll have students that'll come in here and they'll do stuff in StatCrunch and then literally just read it to me. Like that's not helpful at all. That doesn't show that you know anything. It shows that you watched a video and pushed the same buttons I did, but it doesn't show that you know anything if all you do is read the output or show me a picture from StatCrunch. You want to do those things. You want to show me the images you create in StatCrunch. You want to tell me the numbers that you crunch in StatCrunch, but that's like the beginning of the story, right? It's like a first page of a novel. Like that first page, like no one's gonna go, oh, that's a great first page. Where's the other 200 pages? You got to have the full, you want this to be a complete thing. So we'll talk about StatCrunch. You'll learn how to do it. You want to be learning StatCrunch anyways because it's really helpful in doing your homework. You have homework problems that are going to be incredibly difficult to do without StatCrunch, but having StatCrunch makes them really easy. So, and that's a lot of what I want you doing along the way in these projects. These project discussions is a lot of times you're going to be using StatCrunch. So like when we get down here to what's an upcoming one? Is it the visuals? No. Oh yeah, your survey questions summary, and then your project visuals, you're going to do those inside of StatCrunch and that'll be pretty straightforward to do. Trying to do them without StatCrunch, very difficult. So we're not there yet, but you want to be getting comfortable with StatCrunch now. There's a little blue rectangle with a line through it on some of your problems, and sometimes people miss it because it's kind of off to the side sometimes, and if your window isn't open big enough, you'll miss it. But if you click that, it opens the data for that problem in StatCrunch, and it makes the problems easier to do. So it's pretty convenient. Okay, with that said, let's get into some new stuff. So a frequency distribution or frequency table, they go by both, right? Both names. Show how a data set is partitioned among all several categories or classes by listing all of the categories along with the number of data values in each of the categories. Now that sounds super confusing, right? It's like, wait, what did he just say? It just sounded like he was saying random words. So let's kind of go through that a little bit slower. It shows how the data is partitioned among several categories. So partitioned means when you take everything and then you put, like, think of it as putting things into boxes, right? You take everything and you put them in a box. So we're going to do example of ages in a few minutes. I'm going to show you how to do it on StatCrunch. So lots of ways of representing ages. We could represent ages as a single age. So in other words, every 32-year-old gets put in a box. Every 33-year-old gets put in a different box. Every 34-year-old gets put in a different box. But maybe that's not for whatever problem we're working on. Like sometimes that's a good way of representing ages, especially if our sample sizes are small or depending on what we're doing. We may not want individual ages. We may want to put people into groups, right? A common way of grouping ages is by decade. These people are teens. These people are 20s. These people are in their 30s. These people are in their 40s, their 50s, their 60s. So then you're taking everybody that's, 50 to 59 and you're putting them in a box. Everybody that's 60 to 69, you're putting them in a box. Everyone that's 70 to 79, you're putting them in a box. So you're just figuring out, that's what they mean by several categories or classes. We're going to learn that word in a minute. Those are just the different boxes that you're putting people in. So you ask someone, what's your age? Oh, I'm 22. Okay, you go in the 20s box. That's one way of doing it. You might think that you want to have more classes than that. So you might want to break it down as 20 to 24 and 25 to 29, 30 to 34, 35 to 39. That may be how you want to break it down. It really just depends. And these are the things I know sometimes people get irritated with in statistics where they're like, just tell me how to do it. Just tell me, should I have individual ages or should I do decades or every 5 years? Just tell me the answer. There is no answer. With statistics, there's guidelines about like how you should do a thing, but ultimately these decisions are up to you. This is critical thinking. You can't just memorize statistics. You have to look at it and go, I think when I break it down into increments of 5 years, I like the way this histogram presents the data better than if I do it by every 10 years. So then you choose the 5-year one. It takes time to sit down, and it doesn't take a lot of time because as you'll see, StatCrunch just, you snap your fingers and your graph is created for you. You create 5 or 10 of them of the different options, and you go, this one looks really good. And I've kind of mentioned this before, taking that extra 5 minutes to, instead of just use the default values on a histogram, but instead you play around with it and you find this one looks really good, it really makes your presentation look polished. It looks like you spent time on it and that you know what you're doing. When people just throw up the default histogram, usually it's not as good as it could be, and that shows. It shows. So take the time to go, okay, let me try. Let me try every 10 years. Let me try every 5 years. Let me try every 1 year. And if you have any other ideas, try those. And then you look at, say, the 5 of them and go, I'm picking this one. That looks really good. And then you put that in your presentation, and it's going to make you look better than people who didn't take that extra 2 minutes. Your work's going to look a lot better. Okay, so we're taking the data, we're separating it into different categories, these classes, some grouping that we've decided. And everything has to go in there. A partition means you didn't leave any data points out. Everything got put in one of the bins, one way or another. If you're in the class and I'm making a frequency distribution for the class, there is a box that you go in, right? I didn't leave you out and say, well, you're the only one that's in your 50s, so we're just not going to create a bin for you. No. Every data point gets put in a box. That's what partition means. You're dividing everything up, but everything gets divided up, not like part of it. Okay. And then what we do is we count the number of data values in each category. So like for this class, if we were to create, say, teens, 20s, 30s, 40s, 50s, we would expect you could very likely see at least one person in all of those bins, but we would probably see that the teens group and the 20s group would have the highest number of people. Well, we don't want to count those by hand, right? Look at these pulse rates. See, we've got data for females, data for males. Okay, tell me, who has a higher pulse rate, females or males? And you go, I don't know, I just see a big list of numbers. Right, that's the problem, is it's just a big list of raw data. Like looking at those lists, I don't know, do females have a higher rate? Do males? Who's to say, right? But what we can do is we can organize this data in a way that we can start to make conclusions and say, oh, it looks like this group has a higher heart rate than this other group. But we can't say that from looking at this. I don't know. I see some 80s in both. I see some 60s in both. Here's 104. We don't see that much down here, but I do see 90s in both. I don't know. I can't make any kind of conclusions. So what we want to do is create a better way of doing it. So what you do is you would create your bins. So this is a good example right here. Here is a frequency distribution for these pulse rates over here. And it looks like they didn't, for this, I think, oh, it says for females. Okay, so they specify for females. Now, notice what I just did. I didn't know what this graph was representing, this frequency table. I didn't know what it was representing, because I kind of forgot in the last 30 minutes since I looked at it. But see how it's labeled, and it tells me exactly what it is. It is the pulse rates of females. Answered my question immediately because it was well labeled. This is a key. Whenever you're making a graph or a visual in statistics, it should be well labeled. It should answer as many questions as you can by looking at it, because most people are only going to look at the pictures, right? People don't like to read words. They don't like letters. Most people find them annoying and they get bored after 160 characters. You want to put labels on your graph because that's probably all people are going to look at. So you want to convey information that way. So you want a well-labeled graph. It should have a good title. Whatever other variables are included, sometimes it's one variable, sometimes it's two variables. If those variables from your data are included in here, you need to label them and you need to give us units. So in other words, if time is one of your variables, well, is it time in seconds? Is it time in minutes? Is it time in hours? The way you want to think about it is, if I look at your graph and I have to ask you a question about what it means, then you lose. Like, you've not done a good job then, right? So if I have to ask you, well, it says time down here, is that weeks or months or years or days or seconds? What are we talking about? If I have to ask that question, then you've messed up. Okay, if I have to ask you, what does the x-axis represent? Then you've messed up. If I have to ask you, like I was wondering a minute ago, is this for males, females, or both together? Oh, well, it says females right here. So it answered my question before I even asked it, right? So every graph that you turn in for the project needs to be well labeled. If you turn in a graph that is poorly labeled, it is basically putting a spotlight on your work that says, I don't do good work. Okay, so make sure it's well labeled, that you've got a good title, you've got any variables or data that you're using are labeled, and you've included the units. Okay, so if it's height, is that height in inches? Like what do these numbers mean? Okay, now see what they've done here, and this is where you start to have some choices about how you're going to construct your frequency table. They decided to go by tens, which is a very common thing. Sometimes it's appropriate to go by tens. Sometimes it's not the best choice to go by tens, right? You never know until you try it a couple different ways and then see how it looks. Here are the pulse rate from 60 to 69, 70 to 79, 80 to 89. And then what they've done is they've counted how many people fall in that box, right? How many people did we put in the 60 to 69 box? 12. Well, that's really helpful because I don't know that from up here. Looking at the raw data, if I just said, here's the data, how many people fall from 60 to 69? You're going to go, I don't know. Do you want me to count it? Yeah, count it. Okay. And then you go through 1, 2, 3, 4, 5, 6. That's time consuming, and also it's a good chance you make a mistake, right? When you're just scanning through data and you're counting things, it's very easy to miss one, and sometimes you can even double count one. So it's really convenient if we have a frequency table and I say, how many of the females had a heart rate between 60 and 69? 12. Oh, how many had a heart rate between 80 and 89? 11. Right? There's no, like, see how much easier it is to access that data and get the information. So we start to go, okay, so it looks like most of these females have heart rates between 60 and 89. So I'm starting to think that between 60 and 89 is where most females will have their heart rate, and that there's a small number of women that have much higher pulse rates. Okay, so now we've just learned something. We've learned something about what, under these circumstances, is a typical pulse rate for females and non-typical pulse rates for females. And that was much more helpful than just looking at a bunch of numbers up here, right? So that frequency distribution can be very helpful. It can be very helpful on its own. It's also very helpful because it's step one in doing a histogram, and histograms are one of the most used visuals in statistics. So let's see if I can show both of these at the same time. So when I've mentioned, don't just make a histogram. It comes up on your screen. You copy it, you export it, put it in your project, and call it a day. Make a few different histograms. Figure out the different parameters and come up with what you think is the best evidence for the story that you're trying to tell. Right, just like the prosecutor in the courtroom is going to, he or she is going to figure out the best way of presenting the evidence to support the narrative that they're trying to give. That's what you're doing. You're trying to figure out, how can I change all of these parameters in ways that I think best shows the information for the case I'm trying to make. Not to be misleading or trick people, but to show, like, I think this is really important about the data, and my histogram shows what I'm talking about. It shows that we have a gap right here, and then we want to investigate that gap. Whatever it is you want that showing up. So you've got lower class limits, upper class limits. So those are the, here's your class. We have a class that goes from 60 to 69, a class from 70 to 80 to 89. So you've got your upper and lower limits. I think it kind of makes sense. You've got a lower limit, you've got an upper limit, and it says what goes into that group. You've got your class boundaries. So sometimes, depending on the way that the software you're using shows the information, it can be a little bit misleading. Like, I'll show you in a minute when we use StatCrunch that if your age is 20, you can go, wait, I can't tell which bin 20 is supposed to go in because it looks like it's in 2 bins. So what you actually do is create a class boundary that's in between the 2 ages, say 20.5. So then the 20s would go in the group below the 20.5, and you wouldn't make the mistake of putting it in the higher group. So it's just a little more technical way of dealing with these. You've got your class midpoints, which can be helpful to figure out. That just means the middle. What's the midpoint of your class? And basically you get that by finding the mean of your endpoints. The class width is one that is built into StatCrunch, so you'll be using this a lot. So the class width is the difference between 2 consecutive lower class limits or 2 consecutive lower class boundaries in a frequency distribution. So if you're doing things by hand, these are all pretty important. As far as like what you're actually going to do in this class and when you're using stuff, like you might have to mess with all of these while you're doing the homework. But for your project, when you're doing the different histograms, there's really, once you've labeled everything properly, there's really 2 things you're going to mess with. One is the starting point, and then one is the class width. So the class width would mean, do I want to put people in ages where the boxes cover 10 years, like 20s, 20 to 29? Is that how wide I want my box to be? Or do I want it to go 20 to 24 and then have a second box that goes 25 to 29? That width is going to determine how many boxes you have, because if you have really wide boxes, then you have fewer boxes. If you have narrower boxes, then you need more boxes to put people in, right? So that class width is a thing, and I'll show you in a few minutes. You're going to play with that, and it takes, you could make 5 different histograms in a minute and pick the best one. and it just really will look so much better in your project than all the people. It always surprises me how many people have gone with like the default histogram, and you kind of look at it and go, man, that could look so much better if you had just tried like 2 or 3 histograms and picked a different one. Your visual would look so much better. But I'll show you how to do that. So class starting point is, where does this start? A lot of times it's standard to start at a round number, like 60. They started here at 60. Sometimes you start at a number that ends in a 5, like 65. But there's nothing wrong necessarily with starting at 63 and then going to 68 and then 73 to 78. You can do that, but usually if people like round numbers, that is things that end with a 0 or a 5. So sometimes we do that. Sometimes that may not be the best choice, right? And I know it's in that category of like, well, what's the right way to do it? There isn't a right way to do it. There's better ways to do it, but that really matters for the individual problem you're working on. If you're doing a histogram for ages, then you may pick a certain bin size and starting point. And then if you're doing a histogram for the number of hours that people work in a week, you probably are going to choose a different starting point and a different bin size, because it's a different context. It's a different problem. So you got to be flexible like that and go, well, it's a different problem. I got to figure out what's the best one to do. There's no like right answer that says, when you do a histogram, always start at 20 and use a bin size of 5. Like, that's wrong right out of the gate, what I just said. So there's no golden rule for these things. There's directions for how to do these, but you probably aren't really going to be doing these by hand. You're going to be using StatCrunch. So you want to understand how a frequency table is made, and if I forced you to and said make one by hand, you could do it, but generally we're going to let StatCrunch do it for us. It's a pretty straightforward procedure. You're counting how many things go in a certain box. So 60 to 69, I'm just going to count how many of these numbers start with a 6. 70 to 79, I'm going to count how many of them start with a 7, and you go from there, right? So let's see. Do I want to jump over to StatCrunch yet? Let me see. Okay, and then there's versions of the frequency distribution. There's like little different versions of it. But if you understand the basics of what a frequency distribution is, then these other ones should be pretty straightforward. So you can have relative frequency. That shows you your percents. What percentage of the females fell between 60 and 69? 30%. How many fell between 70 and 79? 35%. That's helpful, right? So you can that's another way. You might argue, oh, it's really good if I give those percents. Sometimes you want to give both. Give the actual numbers in one column and then give the relative frequency in another. So people can say, okay, there were 12 people from this group, and that's 30% of the group overall. That's more information. It may make sense for you to give that information. Maybe it just makes sense to give the relative frequency, maybe just the frequency. It depends on what you're doing. Okay, but both are pretty good options to show what you're talking about. You can also come up with cumulative frequency distribution rates. That's a little different, and I would say you're less likely to use that, but you should understand what it is, because in a case where the cumulative frequency distribution is helpful, it looks really good, right? I don't know how many of you have to kind of structure what you're trying to talk about in a certain way to make that work. Cumulative means things are adding up. So you're counting, like the new stuff that comes in, you add it to what you've already done. So notice how here, remember in the original it's like way back there. In the original frequency distribution, I think it went like 12 and then 11. Oh, it would have been 14. So it went 12, 11, 14. But then you go, where does this 26 come? Well, they're taking the 14 that are between 70 and 79, and they're adding them to the people that were in this group up here. So see how it says less than 70, less than 80? Well, if you're less than 80, you're also less than 70. So you're including everything in the group above it. That's why these numbers are continuing to get bigger, because you're including everything above. Okay? You have to be making a certain kind of logical case trying to show the evidence in a certain way for a cumulative frequency distribution to make sense, but sometimes it's a really good tool to use. So don't be afraid of it, but you're very likely to want to use a relative frequency table and very likely to use a frequency table. Those are used all the time. Cumulative, useful, but only in certain circumstances, okay? Oh, right, so critical interior. Yeah, so let's not get into that yet. We'll talk about that. Yeah, we're good on time. Let's talk about that in a few minutes. So let's take a look at StatCrunch first. So StatCrunch, you have access to StatCrunch from your online license. This program costs like if you're not a student who's all doing this, I think it's $15 a month. And if I was in a job where once or twice a week I had to use StatCrunch, it's a no-brainer. I go to my boss and say, get me a StatCrunch subscription. Even though I only use it once in a while, $15 a month gives me all these stat tools, good to go. You do not have to pay for StatCrunch because you got it with your homework license. So if you have completed that whole process of getting your homework license lined up for the semester, you get to use StatCrunch for free until the end of the semester. So don't pay anything more. Don't go to StatCrunch and buy a subscription. You don't have to. It's included with your work, okay? So, you do have to be logged in. That's a thing I see sometimes with students where once I release the data to you, they'll try to go right to it, but they haven't done homework in a while, so they're not logged into the homework system, and so it doesn't recognize that they're logged in for StatCrunch. So if you ever have trouble getting into StatCrunch, just go into one of your homework assignments, and then it should kind of log you in again, and then go into StatCrunch. So what do we have here? Well, you're going to, when we take the survey, what's going to happen is I'm going to release a big page in StatCrunch, and each column will be the responses to a question that was asked by you. So for instance, I'm sure somebody's going to ask, what's your age, right? That sort of gets asked every single time. So what's your age? So what you're going to see, in this case, I changed it because I was just kind of reminding myself how to do everything with StatCrunch before class started. So I already changed it. But it's just going to say var 5. Well, var 5, if you're working on these things, it's very easy to mix up var 5 and var 6, right? Here it's not because I don't have any data for var 6. But you could imagine if every one of these columns had a bunch of data in it, it's very easy to forget what's what. So one thing we can do is go in and we can change the title. So you just click it and say, these are ages. And now I'm going to remember, oh, that's my age. I don't have to remember age is var 5. Var is for variable, right? Go, oh, there's my ages right there, no mistaking it. And then I will have all this data from people who answered this. And I just made up these numbers. But this is, reasonable for what we might see in a classroom. And I go, okay, here's my data. So here's the ages. And I had, 29 people responded with an age, and they put their age here. And here I've got this data. But it kind of looks like when we were looking in the book where it's just a big list of numbers. And I go, I don't know. I see some people that are around 20, a little less than 20, a little more than 20, a bunch of those. That's about all I can say. Few people that are older, few people younger. That's about all I can say from this. So what we want to do is do better than that, right? So frequency. So what you have to learn, and this is confusing because I forget myself, right? The stuff that I haven't done in StatCrunch for 3 or 4 months, that we do at the beginning of the semester, next semester, I kind of forget, wait, where's frequency? So looks like I lost internet for a second there. I think we're back. Okay, I think we're back on the YouTube stream. So basically, I forget where stuff is, and you're learning, so you don't even know where stuff is in here. Most of the things that you do are going to be under stat or graph. Okay, some of them will be under data. We'll use this a little bit. And then, of course, edit. You can edit things, and then, there's lots of other tools in here. So a lot of times people come in here and they're just it's kind of overwhelming. They're like, histogram. I don't know how do I make this thing make me a histogram? How do I make it tell me what to do? There's a couple things that you want to remember, and I see students forget this throughout the semester. It's very easy to go into YouTube if you forget. You want to go, how do I make a histogram again? Go into YouTube and just search for StatCrunch histogram. And somebody's going to have like a 90-second video that shows you, you'll see their screen, and they'll show you going up here, going to graph, and then coming down to histogram right here and clicking it, and then they show you how to use the tools. You go, oh, that's right, that's where it is. You don't even have to watch the whole video sometimes. But that's a good way to do it, is you just look up a YouTube video, and it'll remind you where stuff is. The other thing you can do that I know a lot of students miss, if you go to the bottom of a homework problem, let's see if I can pull one up here. Let's see. See if I can get I don't remember the lessons off the top of my head. I'm going to have to get oops, what's wrong with that one? Let's go to chapter, let's see if this does it. Preview. So you're going to have homework problems that look like this. Let's see if we can find a different one. Okay, yeah, this is more helpful. So let me change this screen here. So a couple of things. See, there's this little icon right here, and you go, what is that? I don't know. Does that look like Connect 4, or is that a checkerboard? What am I looking at right here? So it says click the icon to view the data table. So see all this data right here? You don't want to be like copying that down or typing it into the computer or anything like that. So you click it, and it opens the data for you, and it says, here's the data. And you go, okay, great. And it looks like they've changed the icon here. Oh, click to copy the table. So I'm trying to remember, where is this? Is it here? No, that minimizes it. They changed the way the screen looks. You should be able to open it in StatCrunch usually. Is this one not letting us get into StatCrunch? I wonder why. Anyways, a lot of times it's going to let you open the data right into StatCrunch. But look at this stuff at the bottom. A lot of students skip this part. So you have these options at the bottom that are very helpful. View an example, and they're going to walk you through a similar example, and you can go, oh, that's what they want me to do in that part. Okay, that's very helpful. Help me solve this. I forget exactly, but if you do the help me solve this, I think it doesn't count for points maybe if they're helping you, and then it makes you do another one. I have to remember, but you can experiment with that and see how it works. But also get more help. A lot of times students skip this one. If you go to get more help, it says, well, StatCrunch or Tech Help, what do you want? So if I hit StatCrunch, then it opens a StatCrunch screen for you, and then you can do whatever you want in StatCrunch. And like I say, most of the time they allow you to import the data right in here. On most of the problems, there'll be a little link you click, and it opens there. But if you're trying to figure out how to use StatCrunch, then you go click more help, go to Tech Help, and what it does here is it says, okay, here's how you do the different technology. And so it says, okay, stem and leaf plots in StatCrunch. And then you just follow these directions inside of StatCrunch. So it's telling you, select graph. So right, we were looking at that graph category, and then highlight stem and leaf plot. So let's see, if I go back to my StatCrunch, I go to graph, stem and leaf plot, there it is. So if you can't find something, you look around, go to that part that the Tech Help is going to tell you the directions. It's going to say go to graph, then go to stem and leaf plot, select it, and do this and that. So because I definitely get, and it's fine to email me or message me through Canvas, but I definitely get students that are like, I can't find where this thing is in StatCrunch. So it's just going to be a lot faster for you if you want to do a YouTube search for it, or just use that Tech Help thing at the bottom, and it's going to tell you exactly where it is. So that kind of empowers you to, you don't have to wait around for me to get back to you. You can just do it yourself in 5-10 seconds. So right, and some of the problems, let's see, did it, and we didn't have that. I guess I closed it. But yeah, some of them are going to allow you to open StatCrunch immediately. Okay, so what do I want to do? Well, I'm looking here, and I don't see any frequency table or frequency diagram. Go over here. Oh, it's over here in my tables. Oh, see when I highlight tables, frequency, there it is. There's where it's at. And you're going to do some contingency table stuff in the homework as well. But most people that once you understand a frequency table, the contingency table is more complicated, but it's like once you understand a frequency table, a contingency table is just like one more step, right? It's just a little bit more complicated. So today we're talking about frequencies. So you go, okay. Now watch if I do nothing at all and I just say compute this for me. So I go down and hit compute. It says, what are you talking about? You have to like give me some information. I'm not like a magic box. You got to tell me some stuff to do. Okay. So one thing you have to do is you have to select which variables you want to use. Now I only have one column of variables here, but when you're doing your project, we're going to have, I think I've had in one class, we had like 80 questions. So that's 80 continuous columns of data. And in one class, it was like 140. So we had 140 columns of data. So you have to tell it which one you care about. Oh, age. See how I highlighted it? It says, okay, you want to use age. For some problems, you have to choose two variables. When you do correlation, you have to give it the two variables you want to do the correlation on. So, so just kind of be prepared to pick two things. I think you just use shift if you want to pick a second variable as well, but I don't have a second variable in this one. Okay, and then you've got, I don't remember the where, what that means, but group by, we don't need that. So see how you've got frequency and relative frequency? You can choose which one you want it to do, or both. You can actually have it do both at once, which sometimes is convenient. Order by, value ascending, value descending. So does that mean, like, you want to have things in a reasonable organization, right? In other words, when we did this, where's our frequency distribution? Right here. Notice how there's a very logical manner for pulse rates. It starts at 60 and it continues to go up till it gets to 129, right? We didn't put 60 to 69 and then 90 to 99 and then 110 to 19 and then 70 to 79 where it was just like randomly ordered. That would be confusing because you're like, well, why do we have this weird confusion baked into the system? You do it this way where it's logically, and the two logical ways to do it. Now, there may be rare cases where you really have a good reason for doing it differently, but that's kind of the thing about statistics is if you're going to do something that's different than like the normal thing, just be able to defend it. So if someone asks you, why did you order your classes this way? You go, oh, I have an answer for that. This is the reason that I ordered them in that like what looks like a disorganized way. I did it because of this reason. Otherwise, you probably should just go with like the normal thing, right? Which is to either start low and go high, or you can make the case that in sometimes you should start high and go low. But it's a lot harder to make a case for just randomly ordering the classes here because it's going to confuse people when they look at it. And what you want is you want a visual that is the easiest way to get people the information that you want them to know about, okay? So in StatCrunch, we can either order, so value ascending means that they get bigger. Value descending means they get smaller, okay? So ascending is going up, descending is going down. So you can order them that way. Other percent less than. And then we've got bin numerical values. This is the easiest way to play around with these. So bin numerical values. What do you want your starting point to be? What do you want the width to be? So we won't use that just yet. I'm going to give you like just the basic one where I've used all the defaults. And here we get our, oops, did I click that? It gave me the frequency and the relative frequency in this case, right? So it's both. So when I look at this, how many 17, this is again hypothetical information, but how many 17-year-olds are in the class? 2, and that accounts for approximately 7% of the class. How many 18-year-olds? 10, and that's 34% of the class. How many 19-year-olds? 3. That's about 10% of the class. See how that's helpful, right? It's made up data. But maybe you don't want one of those. So you go in and say, I just want frequency. And then you compute it. And now we just have the frequency. Oops, was it not showing before when I did both? Let's see. Let's do both again. I can't tell if it was off the screen. So you've got, I think it was off the screen before. So like 2 17-year-olds is 7%. 10 18-year-olds is 35%. We can see both of those values there, so you can do it that way. Or maybe you just want one of these. Maybe you just want relative frequency and you just do that one. A lot of times I find like for this situation, not a bad idea to just use both, right? And compute them and do it that way. Now in this case, you might say, well, I don't want individual ages. I'm really concerned about like sort of cohorts, people that are born around the same time, because, you know, a lot of times people that are 20 to 24 have a lot in common. People that are 25 to 29 have a lot in common. You're kind of at different stages of life, right? People that are 20, 24, a lot of times kind of putting their education together, wrapping up their education. People that are 25 to 29 probably finished with their education. Depends on their educational goals and their individual lives, but a lot of people have completed their education by that point, and then they're working on a career, maybe starting a family, maybe having babies at that point. Like, it just, you know, you can break people up into groups, and a lot of times there's a certain behavior that starts to take place in that group, which, you know, is a little harder to do if you're talking about individual ages, right? You're not usually going to go, well, you know, maybe at 26 people are starting to have babies. Well, probably 27 too, and 25 as well. So it kind of makes sense sometimes to just group those together, right? But this, you'll only see this if you make a few of these from the data. So what you do is go, I wonder if I want individual ages, or what if we changed this bin size and the starting point? What if I made my width 5 and I compute it, and it says, and it went through, and remember I talked about round numbers? It just assumed I wanted a round number, so it started at 15. The lowest number in my table is 17, but it might make sense for you to start at a number that just makes the information a little bit easier to understand. 15 to 20, 20 to 25. You could choose another option. You could say, well, we don't have anyone until 17, so I want this to start at 17. And you compute it that way. So it goes 17 to 22, 22 to 27, 27 to 32. You might have a really good reason for doing it that way, and that's okay. There's no rule that says what your bin size has to be and what your starting point has to be. But see how quickly I tried a few different things? And it actually stores them over here. Oh, why is it? Oh, it's because I've only got the one, I think. Let's see. If I close this, see how it kind of went over here, and now there's a little 1 here? If I go down to where it says, see if I can show you. Go down to where it says results. You can grab your old graphs that you made. So they don't like disappear. It just stores them over there. So if you make 5, you still have access to all 5 of them. And then you can look at all 5 of them at once and pick which one you like. Like, let's make another one. So you can look at like, let's see, let's edit this one so it starts back at 15, which I think in this case is probably a good option. So let's go 15, hit compute, and then I want to make another one. So I go here, I go to table, frequency, and this time I'm just going to use the default, just like that. Okay, so now I've got, see how quickly I made 2 of them? And now I can compare. Now that I've got the 2, I can look at them and go, which one's better? Like, which one tells the better story that I'm trying to tell with my data? I would argue this one's probably, you know, better. You might have a reason why you think this one's better, but have a reason. Be able to, if you were to, like, kind of play the game in your head. Like, imagine a little person who's skeptical of what you're doing and asking, why did you make that choice? And then you should be able to give an answer. Oh, I made this choice because I think that this is a little more compact. It puts people in groupings. 15 to really, in this case, 19, 20 to 24. It kind of groups people together that are in similar ages, and it gives us a better idea of what's going on. Okay, if you can justify why you made that decision, then that's good. Don't just make decisions because you're like, I don't know, I have to click something, and so I'm just going to randomly click one of these decisions and go with it. Be able to make a decision. But make yourself, 2, 3, 4, 5 of each of these and go, yep, this is the one I want to use right here. So you can close the other one and then export this one. I would recommend just create a folder on your computer, and then throughout the semester, whenever you're working on the discussion boards for the project or you're working on this on your own, if you get something that you think is really good, just export it and save it in that folder. And then one of 2 things is going to happen. At the end of the semester, you're going to have all this stuff in this folder that you can use for your project, which is going to put you way ahead of people who have no folder. They don't have anything collected. One of 2 things is going to happen when you open this frequency table again, is you're going to look at it and go, oh, I thought that was good at the time, but I know so much more statistics now, I can do better. And then it takes you a few seconds to go back and do a better version. Or you go, man, I really nailed that one. That was good. I'm glad I kept that. That was a good looking frequency table. And then you just put it right into your project, right? And you go, man, I did that work like 4 months ago and I forgot about it, but there it is. It's all ready to go. I still think it's the best looking one I can do. I'm going to put it right in the project. Or you look at it and go, yeah, man, I knew so little back then. Now I know much better. And you just make a new one, whatever it is, right, that you're doing. That's how you're going to go through and make those frequency tables. And it's convenient and helpful. Okay. Okay, let's see. Let me kind of figure out where we are here. Oh, there's an idea of a normal distribution. Normal distribution is a big, big deal in statistics. A lot of times normal that's normal with a capital N. It doesn't mean normal like, sometimes there's a tendency when something's different, we say, oh, the thing that's not different is normal. We don't really mean it in that same sense. Notice how they're using capital N. It's just like a name, normal, that they use in statistics. So don't think that this means like things that are good or bad. If it's normal, then it's good. If it's not normal, it's bad. Doesn't mean that. It's just there's a specific shape, and we call that normal. But there's not like a connotation that comes along with it. The way we're loosely going to we'll build on this throughout the semester, but loosely the way we think of normal with a capital N is symmetric and bell-shaped. So kind of, let's see if we have a picture in here. I don't remember. They're kind of showing us in the form of what it looks like in the table. But if it forms, that bell shape, kind of starts low, you get a big bump in the middle, and then it levels off. That bell shape, and if it's roughly symmetric, data is never perfectly symmetric, but if you fold it over on itself, would it roughly line up? That's symmetric. So bell-shaped and symmetric means normal. And there's certain tools that we can use when we have normal data, which is great. There's certain tools we can't use when we don't have normal data. So it's really important to be able to recognize when you have it or not. So they kind of say here, normal distribution IQ scores from 1,000 adults were randomly selected. The results are summarized in the frequency distribution below. The frequencies start low, right? So the edge of your bell. And then they increase, so you get that kind of bump in the middle. And then they taper off again, the bell shape. That's what they're talking about right here when they talk about your frequencies start low, they get high, and then they get low again, and they're roughly symmetric. So we can see that in the table, right? The one we were looking at a few minutes ago wasn't like that. This one, we had all our data at the beginning. It's high, and then it kind of levels off and get low. That is not normal. And again, normal with a capital N. This would be skewed data, which we'll be talking about a little bit. Don't know if we'll get to it today, but soon we'll be talking about that. Whereas this one here starts low, gets high, gets really high, and then see how it drops down to almost, this 232 doesn't exactly match the 228, but it's close. That's pretty good. That's pretty close. And then it drops down to where this 26 kind of matches this 24, not perfectly, but in the neighborhood. So you can see we start low, get high, come back down again, and the two sides kind of match up. Not perfectly, but it's never going to perfectly match up. But in this case, we'd go, yeah, that's pretty normal, right? You have a bell-shaped and symmetric curve here. And we're not looking at the curves yet, but you'll start to see what that looks like. And normal graphs show up in ways where you don't expect them to sometimes. Sometimes you look at something and you go, oh, that forms a normal graph. Okay, great. Sometimes you'll think something's going to form a normal distribution and it won't. So you want to be able to recognize those things and go from there. Let's see. I think we're going to look at histograms now. Yeah, histograms. So histogram is hugely important. You absolutely should have numerous histograms in your project, right? It's one of the most used visual representations. You should have some in there, show you know how to use them, that kind of stuff. And don't be afraid to use one for each question. It doesn't mean you should, right? Don't use a histogram just because you go, well, I think he wants us to do lots of histograms. Your decisions for the project should be based on what you think best tells the story, but also, like, remember, I'm also sort of trying to figure out what you've learned. So if you don't have a single histogram in the whole project, I'm going to wonder, like, histogram's a major topic. Why do they not have a single histogram in their project? That seems weird. And, but you might have more than one visual. You might show me a histogram. Remember, when you're doing a presentation, whether it's in person or on a video, people want to look at stuff. They like to look at pictures, and they don't like to read a bunch of words. So you may have to put words, and it probably makes sense that at times you'll put words or sentences on your screen, but you want to show some different visuals. So just because you make a histogram for a particular question doesn't mean that you shouldn't also do a pie chart or a box and whisker plot or a box plot or some other visual. You might have 2 or 3 visuals for the same question. That's not a bad idea, right? Because first of all, the person looking at it, you're giving them different things to look at. Like, it's one thing to show someone a histogram. Do you want them to stare at the same histogram for 5 minutes? Probably not. They're going to get bored and start looking at their phone and stuff like that. Give them something new to look at that hopefully gives a different perspective on the same information. So sometimes you'd show a histogram because you want to show them, oh, I want to show you this one thing about my data, so I'm showing you the histogram. But then there's this other thing that didn't show up in our histogram, but it's in our box plot. So now I'm going to show you the box plot. And you can show different things using different visual representations. Well, the first big one is the histogram. Okay, so a histogram is a graph consisting of bars of equal width. Really important that they're equal width, but StatCrunch is going to do that for us. Drawn adjacent to each other without gaps, right? Because if you think about it, if we're making a histogram for ages, well, we'll have a gap if no one has that age. If there's no one from 30 to 34, then we'll have what looks like a gap. But there shouldn't be gaps where you leave out areas, right? So you should have a spot there for 30 to 34, even if the number of people in it is 0. But like in a bar chart, like if you're doing eye color, there's no natural progression of people's eye color, right? It's not like you start with brown eyes and then they become blue eyes and then they become hazel. There's just sort of, some people have different colored eyes. But age is a spectrum. So it makes sense. You would start on the left with, whatever age, 15, and then you would go up to your high age, which might be 45 or something, and you would just go through that range. But there should be no gaps because there is no gap between 33 and 34, right? One day you're 34, the next day you have a birthday and you're 35. There was no gap there, so your histogram should not have gaps either. So people get confused between bar charts and histograms because they look similar, but if you have gaps in there and if you're actually doing a bar chart, then you're making a big mistake. You're doing a wrong thing there. So we want no gaps in there. The horizontal scale represents the classes of quantitative data, so it has to be quantitative. So notice how I said for your questions and throughout the course, you need to understand the difference between quantitative, quantities, and qualitative, the quality, like the description. This is saying that histograms are for quantitative data. So don't try to use a histogram for qualitative data. That's not the right way. Okay, so you have to be comfortable with those data types. Okay, horizontal scale represents classes of quantitative data values, and the vertical scale represents frequencies. You go, wait a minute, we just talked about frequencies when we were doing frequency tables. Right, that's kind of the idea, is that we won't bring it up, but if you look at it, a histogram is essentially a visual representation of your frequency distribution. It's a picture, right? Frequency distribution is still a bunch of numbers. But once we put it in a picture, then people go, oh, pictures. I want to look at those pictures. And then they look at it. Whereas if they just see a frequency distribution, a lot of times, unless someone's interested in it, they're just going to go, I don't know, more words. Give me a picture to look at. And then you give them a picture and they go, oh, it's shiny. And then they kind of look at it a little bit. So make sure that you can sort of understand the histogram is a visual representation of a frequency distribution, right? And look, it even says that right here. They said what I'm getting at. A histogram is basically a graphic version of the frequency distribution, right? So let's go back to our data here. So we've got our ages, and we made, let's have both at the same time. I think I've got well, if we're going to compare them, we'll have to see what we want it to look like. So let's pull that up in a minute. But I'm going to go to graph, and if you look, you'll see there it says histogram, Yeah, let's make that. Let's choose that. So I go histogram. And then it makes me go through those choices. Which column do you want? Oh, I want the age data, even though that's the only one right now. And you want the type of frequency. You can do relative frequency, but probably you're going to do frequency for this one. You've got your bins. Where do you want to start? I don't know. Let's start at 15. And then let's go well, let's leave that for now. And we'll just see what the default is. In fact, I want to see what the default is overall. I think it's going to start at 17. You can color code stuff if you want. You can have it mark the mean and the median. We haven't learned about those yet, but you can have it throw those in there, which can be helpful. I think if I remember right, your homework problems are going to make you do that, where sometimes you mark it with the mean and median, and then I see people doing that on the project. Might be a good choice to do it, right? Maybe you should include the mean and median in your histogram. Maybe you think you shouldn't. It's a judgment call, depending on what you think is best for the thing we're doing. Dividers, we don't want any. Graph properties. You can go through and you can choose a color scheme. So there's different colors. If you're someone who's really into like, oh, I really like pastels, or I want my whole project to be a pastel theme because it's like around, Easter or whatever. You can choose the basic color scheme. And then notice your labels here. I told you this was really important. If you're making something for your project, it is a no-brainer that you will have things on all 3 of these lines, and they should include units when appropriate. So what would be good examples here? Title. Okay, my title should tell you, when you read my title, you shouldn't have to ask me like, what's your graph about? Your title should literally be telling people what the graph's about. So this is ages in hypothetical stats class. Okay. Now, with ages, the unit is obvious because that's how we count. We pretty much always count ages in years, right? So then it's kind of, you probably should put years in there just as good practice. But it's a little bit obvious. But for almost everything else besides age, you should include the unit. If it's time, tell me if that's minutes or days. If it's height, are we talking about height in inches? If it's a weight, are we talking about kilograms, pounds? What are we talking about here? Always include that unit, and it's even a good idea to include the unit in when it's years. But sometimes you'll see people don't, just because we really kind of just use one unit for people's age, unless you're not one yet, and then we tell people's ages by months, but like, because you don't go around saying, oh, how old's your kid? 0. Like, that's kind of weird. So but other than that, just always include your unit. So the x-axis then is going to be age, and I'll just go ahead and put in here in years, age in years, and my y-axis label will be the frequency. If I can spell that right. I think I spelled it right. Hit compute. Here we go. We've got our ages for the hypothetical stats class, the age in years. So people that are in this grouping. And if you hover over it, it gives you some information. It tells you, from 15 to 17.5, because the next one starts at 18, right? This will be 18 and 19-year-olds. And see how it's got the round parentheses on the 20? That means it doesn't include the 20. The bracket, remember back to interval notation, the bracket means include that. The parentheses means don't include it. Because, like when we have our frequency table over here, is it this one? See how this is a little confusing? Because if I told you, what about 20-year-olds? Which box do I put 20-year-olds in? You go, well, this first box is 15 to 20, and this one down here is 20 to 25. And I go, right, so where do the 20-year-olds go? And you go, oh, do they go into both? No, that would mess up our numbers, right? So if you read, it says bins include the left endpoint, and so the implication is they don't include the right endpoint. In other words, this is everything up to 20, so 19.99999, but then 20 actually goes down here. And then this is everything up to 24.99999, 25 goes down here. 29.999, 30 goes down here. Okay, so keep that in mind. That's really what's happening too over here in our bars, is everything up to 17.99999 goes here, and then and then 18 starts here. And you might go, but no one counts ages that way. Right, but StatCrunch, all StatCrunch knows is there's a bunch of numbers. It doesn't really know that you're talking about ages, and it doesn't it doesn't have any context. So you kind of have to watch out for that. So what you could argue that our data starts low, and then it gets high, and then it goes low again. But would we call this a normal distribution? No, because like there's no place where I can fold this. If this was a piece of paper where I could fold this on itself and it would be symmetric, right? It's not really going to be symmetric there. So we would call this skewed one direction or the other. And that skewed behavior sometimes is, if you see data that is skewed, you want to ask yourself why. Why is my data skewed one direction or the other? Sometimes that will give you some insight into your data. For instance, with the ages, we actually usually see more like this. Let me change this a little bit. Oh, actually, I'm getting ahead of myself. One thing you could do if you said, play around with the starting and the bins. Maybe I want my width to be 1, and we compute that. See how it looks a little different now? See how that's a different looking histogram than we just looked at? So again, make yourself 5 histograms and then choose the one that you think is the best choice. This might be the best choice. The one we just looked at might be the best choice. It depends on what you're trying to communicate with your statistics, okay? But don't just go with the defaults. Try a few things and see what works. What was I just gonna do? Oh, right. Let's add some more values in here so I can discuss this a little bit more, so that it's a little more realistic for what we would see at the college. It's just with a low sample size, you're not going to get that stuff as much. So let's go. Okay, let's try this. Let's make another histogram with our age data. I'll just go like that. So this is a little bit more what it looks like, and you might go, well, why is there this big cutoff right here? Why is this one so small, and the next one, the one next to it, is huge? Well, remember, what's the cutoff right here? This bar starts at 18. This one cuts off at 17.99999. Well, most people start college at 18. You leave high school, you're probably 18 when you leave high school. You start college, you're 18. Makes sense we have a lot of 18-year-olds on campus. Also makes sense we have a lot of 19-year-olds. Many people spend 2 years at a community college and then move on. Many don't. I spent 4 years at a community college because I was a full-time student, including summer, for 4 years because I couldn't pick a major. I just was like, I don't know, what about this major? And then try and go, those classes are awful. I don't want to do that for the next 40 years. And then you try something else. So that was back when school was cheap enough that you could kind of, at least community college was cheap enough. Universities were getting quite expensive at that point, but it was still super cheap to go to community college. So like in a couple weeks, I could make enough money to pay for all my schooling for the semester. You can't really, even a community college, that's difficult to do these days. So I did that for 4 years, right? But a lot of people done in 2 years, and you can kind of see that. Oh yeah, you're gonna have a lot of 18 and 19-year-olds. You're gonna have some people that are in the 20s, and then some people coming back to school or starting school for the first time, but at a higher age. That's okay. But we don't see a lot on the left. Why is that? Well, most of the time, if you're under 18, you're probably already in an educational program, and it's probably called high school, right? And it's probably what you're going to. So some students go to high school and college. So like, depending on how local you are or familiar with the high schools, we have both El Camino students. If you go to El Camino High School, which is actually on the Ventura College campus, those students are required to take a certain number of college courses. So you may be in a class with a 14-year-old, right? I've had students as young as 14. If you're younger than 14, you can't really enroll in any classes. And if you're under 18, you have to meet certain conditions to apply for classes. So it's harder for those students to apply. But if you meet conditions, you can attend Ventura College as young as 14, and I've taught numerous 14-year-olds, and they were great for the most part. But there's kind of, you can see why we get less people. There's already a natural tendency for people to be in high school at that age, and if they come to college, if they say, well, I want to take a class at Ventura College, there are certain requirements you have to meet in order to be a 16-year-old on the campus. So that restriction means we're going to have less people here. But see how we're seeing a characteristic in the data, and then I can connect a real world explanation to it. I can say, yeah, this big difference right here is because of the way that the K-12 system works in the United States, along with the fact that there are extra hoops you have to jump through if you want to take Ventura College classes and you're not 18 yet. And, in reality, the more steps you put in front of people, the less likely someone is going to be able to complete that process, right? This is part of the discussion our country is having over voting, and making it that we have essentially since the beginning, is putting steps in front of people for voting and saying, hey, what's the big deal? Just jump through these hoops for voting. Well, the more hoops you put in front of people, the less people are going to be able to complete that process, right? So at the national level, there's these kind of discussions happening for voting, but we can see it in this graph for attending college, right? Oh, there's a reason why there's a big jump right here. I can explain that to you. That's the kind of stuff that is really good in your project. Show me something on a graph and then explain to me why that thing's happening. Here's why we're seeing this big jump. I can give you the reason why. Or you might not be able to know for sure, but you can say, we think that here's why there's this big gap right here. We think this can be explained by this. That's actually statistics. Just reading me numbers out of StatCrunch is not statistics. That's just pressing buttons on your keyboard. But being able to look at this and go, yeah, here's why we think there's this big gap right here. That's what statistics is about, okay? And then, you're giving evidence for that. This picture is part of the evidence. We think it's much easier for a student to attend Ventura College at 18 than it is for 17. Here's the real world explanation, and look, we're seeing it in the graph. You're just like that prosecutor that is constructing a narrative and then giving evidence to support that narrative, right? It's kind of what I just did here. Okay, so let's see. Let me catch my place here. Where am I? So we've got the histogram. We've got the, right. So you can do, just like before, frequency and relative frequency. See how we have percents over here now? That can be helpful. You'll decide which one you think is more helpful, and you'll use that one. This is an example of, this would be called, we would call this a normal distribution. It's low on one side, goes high, comes down again. This thing is exactly symmetric, but you don't have to be exactly symmetric, but roughly symmetric. If I folded this over right here, the left half would line up on the right half, and we'd be good to go. And you could argue that's roughly bell-shaped, right? This would not be, this over here. Those of you who have Excel, you can do a lot of statistics in Excel, but it does some weird stuff, so be careful. Plus, StatCrunch is just way more convenient to work with, and it's a better program. But this would not be a normal distribution. This is not bell-shaped. I've never seen a bell that looked like that, and it's certainly not symmetric. If I fold it over on itself, it's not going to line up very well, right? So this would not be a normal graph. Let's see, we're almost out of time, but I feel like there was something else I wanted to get into. Oh, so we're just about to get into the other types of graphs. Okay, well then it doesn't make sense to do that with just a few minutes left. So next time I will show you more types of visuals that you can use, but a histogram's a big one. So definitely make note, I should have some histograms in my project, right? And then these other ones you can use additionally as you think that it fits the data that you want to include, right? It looks good if you have a few different visuals versus just like, oh, I just went with the histogram every time. It's probably not a great way to do it. Histograms are good and probably necessary, but they're not sufficient, meaning you need more than just histograms, okay? So we'll talk about that, and we'll also get into, probably next time, we'll get into our discussion about bad graphs. Bad graphs can be unintentional by people who don't know what they're doing, so sort of incompetence. Bad graphs can be done intentionally by people who want you to, they want to convince you of their point of view. They want to sell you more cigarettes. They want to continue dumping in the environment. They want to continue putting carbon in the environment, that kind of stuff people can mislead intentionally. So we want to be able to know when I should trust a graph, when I shouldn't. We want to know what makes a good graph and what doesn't. We're going to have those kinds of discussions and talk about how that's going to look going forward. So, whoops, the page number is not showing up there. So that's what we'll do. So continue working through these. So the first set of homework was due a couple days ago, it looks like. You've got your next set of survey questions are due February 6th. Don't wait till February 5th to start doing this. Get together with your group now, so that gives you some time to think about it, because again, I can't stress enough. If you don't plan properly at the beginning of a statistics, like not just your project for this class, but also in the real world, if you start off and trying to not do a whole lot of work or not plan properly, you're going to feel that lack of effort the entire project. You're going to feel it all the way through because your data is going to not be good. So take some time now to make sure you and your group agree that you've really got those questions written as well as you can. Everyone needs to leave a post in here. It's up to you how you want to do it. You can just split them up. Say, okay, we got 3 people in this group. You do the quantitative questions. You do the categorical question. I'll do the yes-no question and put them up there. You're not going to get marked down because you only have one question. If I see one question, I'm going to assume that you're part of a group and that you split the questions up that way. The problem with everyone posting all 5 is I'm going to end up not recognizing all the duplicates, and then you might have to answer the same question a couple times on the survey, and we don't want the survey to be needlessly longer than it should be, right? We want it to be just as long as it should be in order for us to get it done, right? So it is not too soon to start working with your groups on the survey questions. And then you should be starting to move through chapter 2, where we're going to be discussing, qualitative data, quantitative data. Remember, qualitative, you put things in a category like eye color. Quantitative, you're measuring something like age or height or weight. Okay, so you have those, and then we've got the popular displays for those. So ways of displaying the data, and then your misrepresentations of data, which again can be done accidentally or oftentimes done on purpose to mislead you and to scare you, to put fear into you. That is a thing that is regular with statistics, especially since a lot of people are uncomfortable with statistics. If you're already kind of uncomfortable and I'm leading you through a statistical graph and you're already kind of trusting me because you think that I know much more about the situation than you do. So you're kind of putting some faith in me, and then I can make you scared a little bit. I can make you panic a little bit. Then there's a good chance at the end you're just going to agree with me and you're going to go, man, I don't know. He seems smart, and also like some of the stuff he said was scary. I'm just going to agree with him. That we want to be better than that, right? We want to do a better job than that. We want to be genuine and ethical and just do a good job in general, right? So we'll talk about that kind of stuff. And then at some point, we'll get that survey ready to go. But that's not until I have your survey questions and then I create the survey from them, right? So that's kind of where things are going from there. So good work, everybody. Keep up the good work. Please make sure that you've done some homework so that I don't end up dropping you. Make sure that you're progressing properly in the class anyways. Excuse me, I got the hiccups all of a sudden. Make sure that you're progressing in the class properly. Don't really want to get behind in this class. Even if it seems easy now when you're looking at quantitative and qualitative and go, yeah, I get it. Eye color versus age, I get it. We are going to move into, sort of each chapter we do here will get more and more complex. And it builds pretty quickly to the point where I can guarantee by the end of the later chapters, everyone's going to be confused, at least at the beginning. When you're first starting the chapter, you're going to go, what is this? What is going on in this chapter? This is weird. And it takes a little time and some practice and some experience to go, oh, I see what's going on here. Because it's some of these concepts are very easy. If you just do it really quick, you go, yeah, I get it. I push some buttons and StatCrunch did this and I know what to do. But you don't really understand the subtleties of what's going on in some of these tools. So it's important that you're setting yourself up to have the time to let these ideas kind of float around in your head a little bit and go, oh, that's what he was talking about in class. I didn't understand what he said, but now I get it. Now it makes sense what he was talking about. So, set yourself up for success, basically. So I'm going to shut down the YouTube stream. Anyone who wants to talk to me, please jump into Zoom, and I will discuss anything you want. Did anyone come late? If anyone came late, make sure, basically after I took roll, make sure that I have you so that I don't end up doing a drop that shouldn't be dropped, okay? Otherwise, thanks, everybody. I will see you. Okay, I got you, Javon. Thanks. I will see you next time. So just continue to progress with the course, and thanks, everybody.